Good morning and welcome to our fourth session on evaporation. In the previous session, you studied how to determine the boiling point elevation or the appropriate temperature at which evaporation should be conducted. As promised, let me give you the answer to question of example 1. Using the chart that we discussed previously, you'll be able to find out that the boiling point or the boiling temperature of the solution is 207 degrees Celsius, 207 degrees Celsius, which gives you a boiling point elevation of 37 degrees Fahrenheit. Now, you will recall that it is desirable to have a high steam economy. But when you use a single effect evaporator, the highest that you can obtain is 100%. But practically, you always have steam economy less than 100%, 60, 70%. But uh, there are strategies which have been devised in order to improve, to increase steam economy. That is to ensure that with small amount of steam, you manage to evaporate a huge amount of your solvent, and that will improve, of course, the economics of your evaporation process, because steam will always cost you something. Now, one of the methods to improve steam economy is vapor recompression. The vapor phase, instead of being condensed and discarded, is reused to heat up your feed. How does this happen? When you compress a gas or a vapor at constant when you compress um, a vapor, knowing that pressure times volume over temperature is constant. When the pressure is increased at constant volume, then the temperature will also increase, which means that by compressing under isochoric conditions, it means at constant volume, you'll end up with an increase in the temperature of your vapor phase. With that boost in enthalpy, you can heat more your feed. Now, the other strategy is to use what we call multiple effect evaporators. It means instead of only one stage, use two or more evaporators, one after another. There are two different varieties. We have what we call forward feed, triple effect evaporator, triple effect when you have three, but you can have a double effect with only two. It's not surprising to have 10, 20 evaporators. And uh, we owe to history of science the knowledge that some people used in the past up to 70 effect evaporators. Now, in the forward feed multiple effect evaporator, the vapor of the first effect, instead of being discarded, because it is still hot, that vapor is hot, so it's used to heat up. Instead of steam in the second effect, they use the vapor from the previous. Now, the vapor from the second effect is used to provide heat to the third effect. So each effect each effect is using as heating medium, as heating stream, the vapor from the previous one, except of course the first effect, which is using steam coming from here, and its condensate is collected there. It's also interesting to note that in the forward feed, the feed and the steam are both supplied to the first effect, and they proceed in the same direction. You see, whereas in the backward feed, the steam is supplied to the first effect, and the feed is supplied to the last effect. So the feed and the steam proceed according to opposite direction. And here again, the vapor of a certain effect is used to provide heat to um, uh, the following, means the next effect. In terms of calculations, no basic difference. Now, here is an example, a worked example that you can read at leisure in our textbook. That example allows you to understand how mass and energy calculations can be undertaken around a multiple effect evaporators. In this problem, we have three effects. The flow rate of the feed is provided to you, as well as the heat transfer coefficient, the pressure in the first and the last effect, as well as the pressure at which steam is provided. The questions are, we have to find the evaporation temperature at effect number 1 and number 2. We have to find the flow rate of the steam, as well as the solution flow rate M1, M2, and M3, which are leaving the three effect of the evaporator. The problem is quite interesting because it's a practical application of material and energy balances. It allows you, depending on your target, on the specification of the final product, it allows you to tell what should be, for example, uh, the flow rate of your steam to ensure that the whole process meets the requirements. Uh, the solution which is suggested in the textbook is provided to you. I would urge you to read it carefully. It's an iterative method that is easy to understand. Please go through the method, and we are going to discuss it in class. It's quite straightforward, and it's also true that although it is straightforward and easy to use, this method is a bit lengthy, and it involves some abstract applications. When you read it, you'll realize that uh, there are a lot of steps which do not rely on tangible uh, engineering knowledge. That's why this semester we are going to introduce another procedure which will draw us closer to the practice of chemical engineering. Now, just for your information, as I told you, the solution provided to you is an iterative method. First of all, you have to estimate the temperatures, which is done here. After estimating the temperatures, you are going to estimate the flow rates. After you have estimate the flow rate, you can start the first step of iterations, where you use all the equations provided for material and energy balances, and so on. In step number 2, you calculate the surface area.